percentage change in your angular momentum. Percentage change in your angular momentum. That will be equal to how much beta? Omega final minus omega initial divided by omega initial into 100. I told you every time. Final value minus initial value divided by initial value into 100 will give me the percentage changes. Omega final, how much we got? Omega by 3. Initial is omega divided by omega into your 100. That is 1 by 3 minus 1 is how much beta?
Sir, minus 2 by
1 by 3 minus of 2 by 3. Minus of 2 by 3 into 100. అంటే ఎంత అవుతుంది ఇది?
yes, sir.
Minus of 200
Minus
divided
200
by
by
3.
yes, sir.
18 అంటే minus of 66.7%. That means
Yes.
angular momentum of the particle, percentage change in your angular velocity kada, sorry. This one is your
Yes, sir.
angular velocity. Velocity omega kada. So it is decreasing. So it is minus of 66.7%. Is it clear?
Yes, sir. Yes, sir.
So that is a way how do we do such type of questions related to your angular momentum of your particles particulation. Clear?
Yes, sir.
Moment of inertia కూడా ఉంది కదా ఎగ్జామ్ కి.
Yes, sir. Sir.
స్టార్టింగ్ ఏమైనా గుర్తున్నాయా మర్చిపోయావా?
Yes, sir. Yes, sir. Sir.
Let me revise you some questions related to moment of inertia beta. See this question. Find the moment of inertia. Number 1. An axis passing through A. An axis passing through A and perpendicular to the length beta. Perpendicular to the length. This is given for me like this. This is your rod. This is your center of mass. Okay. And this is your axis. And from here to here, this distance is L by 4. This one is mass capital M. Okay. Length of this one is total L. Total length is nothing but of your capital L. Okay. So find the moment of inertia about an axis passing through your A. This is your A. Passing through your A and perpendicular to the length beta. Perpendicular to the length. That axis is how much distance beta? This axis is a distance of L by 4. So they are parallel to each other beta.
Yes.
Hello.
Sir.
These two are
Yes,
parallel, but I can apply the parallel axis theorem beta.
parallel
Moment
axis
of
theorem.
inertia
Yes,
about your A will be equal to your moment of inertia about passing through center of mass plus of your M into your R square. You know the moment of inertia of a rod passing through center is how much beta? M into L square
MR
divided by 12.
by 12. Yes. Sir.
Isn't it? Plus this one
Yes,
is
sir.
your capital M. This R value is how much for me? L by 4. So this one is
L by
L by 4 whole square.
whole square.
So this
Yes.
one will become how much for me? M into L square by 12 plus of your M into your L
ML
square
square
divided by
by
4
16.
into 4 is nothing but of your 16. So ML square is
Yes.
common. 1 by 12 plus 1 by 16. ఎంత వస్తుంది చూడు?
Yes. 1 minute.
Yeah.
Sir, 48, sir, LCM. No?
Okay, LCM is 48. Yeah, this one will become for me common ml square.
Yes, sir.
So this will be equal to how much? 7. Okay, so
Yes,
this
sir.
one is 7 into ml square by 48. Got it?
Yes, sir.
Sure. One more, number B. An uniform disk. An uniform disk. Okay, this is your disk, beta. Axis is completely passing through diameter. This is ICM gada. This one is completely passing through diameter, and this axis is just touching one end and going like this. This is the distance of your R. Now, tell me how do you apply the parallel axis theorem? This is about your A. Parallel axis about your A is equals to moment of inertia about passing through center of
ICM
mass
plus
plus M into your
MR square.
the distance of your R square. What is the
Yes,
moment
sir.
of inertia about your center of mass? That means passing through diameter kabatti. This is the moment of inertia of the
ML.
disk about the diameter plus of your M into your R square. Diameter moment of inertia is how much beta? Mr square divided
MR
by
square
4.
by 2. 4.
So this
Okay.
one is M
Okay,
into
yes,
R
sir.
square. Because ID is equals to how much for me? Iz by 2. Avuna kada.
Yes,
Iz
sir.
is equal to for me Mr square by 2
MR
into.
square by 2. Okay,
So this
yes,
one
sir.
is
Got it, sir.
Mr square
Because
by 4.
radius
1
it
by
is
4
2,
plus
that's
1.
why.
Yeah. So this one is Mr square common. 1
Yeah.
by 4 plus 1.
Sir, 5 MR square by 4 will be.
5 Mr square by 4. Vachinda?
Yes, sir.
So if I give you same condition like this, if this is your same condition, beta, same condition, axis is completely passing through diameter, and one more axis is been passing through this one somewhere right now here, which is at a distance of your r by 2. This is your r by 2, and this is a point A. So this is your completely passing through center of mass. That means this is completely passing through diameter. So what is the formula
Yes,
again,
sir.
beta? IA is equals to your ICM plus of your M into
MR
your R
square.
square.
Yes, sir.
Sorry, M into your small r square. M into your small r square. What is
Yes,
the
sir.
moment of inertia about the center of mass of this disk? It is completely passing through
Sir, it's
diameter, no?
diameter, that's why it's MR square by 4.
Mr square by 4 plus small.
This
This
will
is your
become,
M R by 2.
yes, sir, R by 2.
Because this distance is given in the problem R by 2.
Yes,
Now it
sir,
is not
yes,
at
sir.
one end. So
Yes,
this
sir.
one is your M into R square by 4 plus of your
Plus
M into R
R
square
square by
divided
4.
by 4. 1 by
MR
4
square
plus
will
1 by
get,
4
sir.
is how much?
MR square will get, sir.
Uh, uh, uh,
Sorry, MR square by 2, sir, sorry.
Mr square by 2. 1 by 4 plus 1 by 4 kada. Mr
Yes, sir.
square by your 4. Got it?
Yes, sir.
Okay. So like that we can do the questions related to the given conditions. We bar practice channel, then only you can do some good questions related to this one. Okay na? Let's see one more example. We got 3 uniform circular disc beta. We have been touching like this. This is one. This one. These are disc. We have got 3 uniform circular disc, each of mass how much beta? Capital M. This one is also capital M. And radius of everything is R. Then radius వచ్చేసి R. Then radius వచ్చేసి R. Then radius వచ్చేసి R. All of them are having the radius how much beta? R. Radius of this one is R. Radius of this one is also R. Okay. Are being placed touching each other on an horizontal surface. Like billiard balls when you play. 3 balls have been kept like this something.
Yes,
Or
sir.
points kept like this basically. Such
Yes.
that they are forming right now what? An equilateral triangle. It
Triangle.
is
Yes,
forming an
sir.
equilateral triangle with the center of the 3 discs which have been joined. Then center, then center, then center are being joined. Find the moment of inertia about an axis passing through center of the system of the disk and which is perpendicular to the plane. That means there is an axis exactly passing through this one. So this axis is passing through center like this and perpendicular to the plane like this. Okay, na?
Yes, sir.
Something like from above you are inserting from the center. This is your axis part of relation. Okay. Now you already know that from basic geometry, the distance from one corner to centroid, one corner to centroid, and one corner to the centroid in the equilateral triangle. Also, last time I told you. So this will be equal to how much for me? Equilateral triangle. This is a distance d. So the distance d will be equal to how much for me? 2r by your root 3.
Yes,
Why?
sir.
Because this is r, this is r. So this total distance is how much for me? 2r. This one is also 2r. This one is also 2r.
2 hours. Yes, sir. All of them are
Isn't it?
2 hours.
An equilateral triangle కాబట్టి this total 60. One will become for me 30. So you can easily calculate the distance right now, isn't it? So if you
Yes,
need
sir.
to draw, you can take the diagram here also. This is your equilateral triangle which has been forming. It is centroid kada. This distance. This is your D. This angle is how much for me? 30 degrees. Okay. So from here to here, this one is your R. Okay. So this one is nothing but of your D. So in the same way, right now here also the same thing right now. Okay. So this one is your centroid. So from center to this one, this is one distance, and from center to this one, this is another distance. Ante kada?
Yes,
So
sir.
this is your D part of relation, isn't it? And even in this one, this distance will become, this total is nothing but 2r kada. So this one is your R, and this one is nothing but of your theta. This is nothing but of your 30. Now tell me cos 30 value is how much from this one? This one is one side like this. This is exactly perpendicular. This is your exactly perpendicular. This is R, this is D, and this one is your 30 degrees, isn't it? So if this is your 30,
Yes,
if
sir.
I resolve this is 30 part of relation beta. So this D in resolve just
R
make it
by
D
R
cos.
by.
This one is your D into your sin 30.
Yes, sir.
Okay. So this is your D sin 30 kabatti. So I need to calculate what this distance kada, centroid distance. Adi avasaram ledhu. So centroid
Yes,
distance
sir. Only
kavalante,
R by D will get.
yeah, R by D is how much beta? R by D is equals to this side by this side is how much? Cos theta kada.
Yes, sir. Cos 30 that will.
This one is a D. So D is equals to R by your cos 30. Cos
Yes,
30 is
sir.
how much?
One root 3 by 2, sir.
Root 3 by 2. So that is the way how we got this distance. Okay.
Okay.
The distance
Yes,
from
sir.
center to center. Okay. Now moment of inertia of the
Yes,
disk
sir.
will be equal to how much beta? Moment of inertia of the disk about the own axis will be equal to how much for me? I is equals to m into r square divided by 2 gada.
Yes, sir.
Now we need to calculate the moment of inertia about the center. So this one, this one, this one. So if I'm calculating for any one, isn't, I can apply the parallel axis theorem because I know the axis passing through center. Isn't, you take one more axis for this one
Yes.
which has been passing through center and parallel to this one. So if I take the axis like this right now, which has been passing like this, isn't it? You రెండింటి మధ్యలో distance ఎంత ఉంది right now? See right now, ఈ distance will be equal to this one, ఈ perpendicular distance, ఈ రెండింటి మధ్యలో distance. అంతేనా?
Yes, sir.
These two are parallel. These two are parallel, little bit inclined. So that means I will be equal to how much for me? Moment of inertia for the one disk I'm writing. That will be equal to your ICM plus of your m into your d square. Moment of inertia for the disk passing through center is how much for me beta? Mr square by 2 plus of your
Yes,
m
sir.
into d value is how much for me? 2 into your r divided by your root 3 into your whole square. So how much I'm getting this one? M into your r square divided by 2 plus of your 2 square is how much for me? 4 into m into r square divided by your 3. Antena?
Yes, sir.
So in this one, mr square is right now out. This one is 1 by 2 plus of your 4 by 3. ఎంత వస్తుంది చూడు ఇది? LCM ఎంత వస్తుంది?
6 వస్తుంది, sir. LCM.
LCM is 6.
We'll get 3 plus 8.
That
11 by
means,
11 by 6, sir.
yeah, 11 mr square divided by 6. So this will be the moment of inertia
Yes, sir.
because of how much? 1 gada.
Yes, sir.
This is because of one disk. This is only
Yes,
because of
sir.
one disk. You're having one more disk here. We are having
Yes,
one
sir.
more disk like this here. So totally how many disks right now? 3 disks kabatti.
3 discs.
Moment of inertia about your O will be equal to 3 times of your I1. So that is your 3
Okay.
into, this one is 11 into m into r square divided by 6. Okay na?
Exactly. Yes, sir.
ఎంత అవుతుంది? So
Sir,
I
11
naught
by
will be
2, sir.
11 into
11
mr
mr square
square divided by 2.
by 2.
అంతే కదా? 3 ones are 3 twos are. So
Yes,
this
sir.
is your answer for me. Clear? Very good question, beta.
Yes,
Please
sir.
try to do it once. Okay, na?
Okay.
Okay, chalo beta. Then take care. Bye.
Thank you, sir. Bye, sir.